All right, good morning. I can hear the mic is working. Great, welcome. So that's a strange resolution. So today we will have a look at SharePoint for the DBA. Before we move on, I want to introduce myself. I'm Régis Baccaro. If I sound like Inspector Clouseau with a Danish accent, it's because I'm French and been living in Denmark for quite a long time. So that's the reason. I currently work for IBM in Copenhagen, and I'm not very popular because I go around and speak about Microsoft technologies. But during my career, I've been working a lot with .NET development, with SharePoint, and with BI, and once in a while as a DBA. I'm also the founder and the organizer of SQL Saturday in Copenhagen, which takes place next March the 29th, so I hope you will be able to make it, some of you. All right. So for this one, 10 years ago, I had a boss in the company I was working. So it was in 2003, and say, hey, look at that, this is SharePoint. This is your new best friend. And then he quit, my boss. And I was alone with SharePoint and have to cope with it. So why SharePoint at a SQL Server event? DBAs, they want control over the databases. If you let SharePoint take control, they will look very messy on your databases. And the SharePoint admins, they want control over the SharePoint farms. So obviously, they need to speak together. We will have a look at what SharePoint is for a platform, how you plan a SQL Server installation for SharePoint, how you do maintenance, how you deploy and the configuration, and how you can obtain high availability. I will try to do some demos during the presentation. It's on 3 virtual machines on my laptop, so expect the worst. So what is SharePoint? And why is a SQL Server so important for SharePoint? SQL Server is a central store for all SharePoint data. And if you have stress on the SQL servers, you will have stress on the SharePoint farm, on the front-end servers at least. So a quick introduction of what is SharePoint. SharePoint is quite a broad platform, as you can see, where you have some solutions which are restricted to a few users, and others which are meant to be one-to-many communication. If you can find some specific products which can a lot more than those blue bubbles for SharePoint, but SharePoint is the only platform where you get everything in one box or in one solution. So this is why mainly customers buy SharePoint instead of going to a vertical vendor or homegrown solution. So SharePoint has evolved a little bit since the beginning, where it was called STS, and it was around 2001, I think. It was built on the Exchange public folders. And then came the first .NET framework and the SharePoint 2003. Sorry. And after that, 2007, where they began to take their own medicine and build the administrative side of SharePoint in SharePoint. 2010, and now 2013, where more and more features have been added and also demanding more and more from the SQL Server. Has any of you worked with all the versions? 2003? Still? No? I have one customer with 2003 running on SQL Server 2000. Yeah. So SharePoint is can be very fast, is very broadly adopted, and is also very adapted. So very fast, like that. Ferrari.com is made in SharePoint. Volvo Cars Corporation uses SharePoint also. And for something more fun, Hawaiian Airlines uses SharePoint as their website. So where you can book a trip to Hawaii is only a web part on a SharePoint website. So this was the nice part. Now the ugly part. This is the architecture. Maybe simplified. So mainly you have your admin, I need something to point at. You have your admin database with this old site collection and some databases for the admin web application. And for every web application, you have one or more site collection, and you have one or more content databases. And then you have service applications, which helps you giving you more functionality into SharePoint. And these service applications, there are quite a few of them, and they have one or several databases attached to. You can, if you feel like, also build your own service application, but there is enough to take from already there. Okay, so it's a bit of a paradigm. It's a single data platform, but it's used in very different ways. You have the web content management, where it's mostly read, one-to-many communication, and you have the enterprise content management, where users do ad hoc queries and also do some more heavy writing. You need to be consistent when you upgrade and patch your servers. If you have a farm with multiple servers, you need to upgrade all of them, patch all of them at the same, well, one after all. And your SharePoint application logic relies heavily on the SharePoint data schema. So if you start by installing SharePoint, you don't want to end up with that. If you let SharePoint control the installation, you will end up with some ugly database names, mainly consisted of GUIDs, except some of them. So this is not the good idea. The basic installation, it will use SQL Server Express, and then you're stuck with that. If you use the wizard installation, you can have a real SQL Server, but you don't have control over naming. The first wizard actually is called the gray wizard. So you go in and specify what's the name of your database server, what's the name of your configuration database, and then it's out of your hands. So not much control there. After that, SharePoint comes with a page asking you if you want to configure things yourself or you want SharePoint to do it for you. And guess what? This page is white. So this is the white wizard. If you let SharePoint do it, again, it will create, it suggests all these service applications, and it will just give them horrible names on the database. So this is not an option. What you need is at least use PowerShell to get control over the naming of the databases. And what you also can do is pre-create the databases so they will look like what you really want them to look like. And then SharePoint will say, oh, this database already exists. I will use it. So no wizards here. Okay, so let's have a look at the SharePoint database. There are three types. There are the administrative, the one we saw on the left side, and there are content databases and all the service application databases. So well, how many are they? How large do they need to be, and how fast will they grow? So that's what we will look at. So when you install SQL Server for SharePoint, make sure that you have a dedicated instance, and it shouldn't be a non-default instance. And for SharePoint reasons, it's good to use a SQL alias when connecting to the database. Then you will be able to move stuff around without any problem from the SharePoint side. If you don't set the max stop to 1, it will complain. And you won't be able to install. All SharePoint database needs to have this default collation, case insensitive, accent sensitive. It's a good idea to, after installing the SharePoint, when installing the SQL Server for SharePoint, to specify the right collection, then the model database will get the right collection because it cannot be changed afterwards. So make sure that the model DB is the way you want it, and when SharePoint creates a database, it will use the model DB. You need to do some modification to the system database. The initial size, the auto growth, and also the model DB, as I suggested before. So you need to take care of that also. And then we have the content databases. Each web application has at least one site collection. It can have many, but at least one site collection. And each site collection is contained in a single content database. You cannot span a site collection across several content databases. You can have several site collections in one content database, but not the other way around. So if you have a big site collection in a content database, like bigger than 100 gigs, it's a good idea to move it to a dedicated content DB. Of course, the size depends on the amount of content, and your Temp TB should be at least 10% of your largest content DB size. So to find out how large your database, your content DB will grow, there is this simple formula, where D is the number of documents, V is the number of versions you keep per document. In SharePoint, I'm sure you know, you can't version your documents and decide how many old versions you want to keep. Then the average size of document is S, and then there is this 10 kilobytes of metadata per document for list items. So if we assume that we have 200,000 documents with 2 current versions, and the average size is 250 kilobytes, it will give you a content database of 150 gigabytes, roughly. That was for the content database. There are quite a lot of other databases in SharePoint. And I will explain how they grow and if they are read or write heavy, and which way to scale. So the configuration database, it's the first one which is created or used in SharePoint. It contains data about your Internet Information Service settings, your web application, your farm level solutions, your web part packages, and stuff like that. It doesn't grow very big. If you want to scale, the only way is up. The SharePoint admin content, it's the content database for the administrative side of SharePoint, and there shouldn't be much changes there. So it won't grow much either. And they're both in the full recovery model. Then you have the search database. When you create the search application, SharePoint makes 4 databases for you. And these databases are growing in several ways. The first one is it contains all the configuration for the search application, and it will grow depending on different factors. It will grow on depending on the number of best bets. Every time you find a result and click on it, SharePoint will save this, and it will get a higher ranking next time you do a search. It depends on the number of content sources, the number of crawl rules, the security description for the crawling, and the amount of traffic. The analytics database is quite write intensive during analytics. And usually you want to schedule this update to happen during off hours. And you need to scale out when the database gets bigger than 200 gigs. The crawl store, it is where the results for the crawl are stored. And each time you have a crawl that reaches 10 million items, you should add a new crawl database. The link database, the link store database, it grows approximately with 1 gigabyte per million document. So, yes?
Did you see that the scaling was out on the search service application analytics before you stored it?
No, I'm sorry, up. Yeah, sorry. Yeah, sorry. And the link store is out, scaling out by creating additional link database. Around every 60 million document crawled, you can add a new database. So, and then the size also depends on the click-through ratio. So, and it grows with the query traffic. This is the only service application which requires so many databases. The next one only requires 3. We're lucky. So it's the profile DB where you can synchronize your, for example, Active Directory with your SharePoint, and it's a two-way synchronization if you wish that. So changes made in SharePoint can be replicated to AD, which is not always a good idea. But you can consolidate different providers of information of identity on your SharePoint. So the profile DB, this is it will grow in a way. If there are more users, it will grow, and if the users are using heavily a newsfeed, this is what also will make it grow, and of course the amount of activity on those newsfeeds. The sync DB. It will also grow depending on the number of groups and users and the ratio of users per group. The social DB will grow not much, 0.009 megabyte per tag. So, but depending on how much you use this part of SharePoint with the tags, the rating, the notes, and so on, it will grow accordingly. Other database, there are a few others, but I've taken 3 of them. It's the Secure Store Service database, where you can securely store some service accounts to be used in other applications. The Session State database and the Business Data Connectivity database, which is quite critical when you connect to external data. And some other service database like Performance Point Services or so on. Okay, any questions so far?
The Secure Store Service database.
Yeah.
It contains credentials here and there.
Yeah.
Is it encrypted the way reporting services is?
Yes, mostly not exactly the same way, but it's encrypted and saved into this. So every time you add some new credentials, it will grow. But I never met a secure store service database with more than 20 credentials. So, and the other service application, they rely on the secure store service database to do credential mapping. All right. So a few words about sizing and architecture. When is a SharePoint farm little, or when is it big? Usually, if your content DB is less than 50 gigs, then you call it a small farm. If it's bigger, but not bigger than, it's around 50 gigs, it's medium, and more than that, it's a large farm. And then the number of users also changes accordingly. So for those farm sizes, the recommended minimum capacities are listed here. If you want a balanced system, you usually calculate with 4 gigs memory per CPU core. When you configure SharePoint, it's a good idea to always install the latest service pack and cumulative updates, which sometimes can be doubtful if it doesn't solve any of the problems you have, but mainly it's a good idea. If you're doing anything else than a small farm, it's good to use a dedicated SQL server. But the key to success is the right planning. You need to plan for the current needs, but also for being able to scale. You have to plan for manageability and, of course, for monitoring and performance. The software boundaries, the hard boundaries, the hard-coded software enforced boundaries, they are known in SharePoint. The soft limits, which came from test or supporting recommendation, say that if you have more than 8 web front-end servers, you should add a SQL Server instance. And also, if you have more than the limit should be around 50,000 site collection per content database, and again 100 gigs of data per content database. Also, some lab testing has given okay result with larger content database up to 350 gigs. Of course, you need to have a very short latency between the web and the database servers. Okay. So when you configure and install your SQL Server, you should prioritize the placement of the database files in this order, where the Temp TB has to go on the fastest, and then the DB transaction log, the search DB data files, the content, and then the profile. You want to put them on separate loons, and use multiple data files for content and search DBs. If you can, place SharePoint search, crawl, and query processing on separate spindles. But the key here is to distribute equi-sized data files across a separate disk. And also, multiple data files are not supported for other SharePoint databases than these ones. So it's not an option for the performance point service database, for example. Okay, so the Temp TB, I guess it's general for good SQL Server performance, that you need to have several data files allocated, 1 per core CPU to a limit of 8. And the size of the data file should be consistent across all the data files. And the log file should be on their own loon. So to find the optimal Temp TB data file size for SharePoint, and it's very small on my screen, there is a formula where you take the max DB size of your content database and time it with 0.25 and divide by the number of cores. Then you should find the optimal data file size. When you start, so it should be around 25% of your largest content or search DB. Then you should be on the safe side. If you're using RAID 1.0 is a good idea also for the other database objects, which are not so heavy, where there is not so heavy writing, like content and search. And when you use autogrow feature, set it to a fixed amount, not a percent. The server memory, max server memory, should also be set. And again, it's a SQL Server setting, nothing special for SharePoint, but there is a formula to calculate it. Or the easy way, just leave 2 or 3 gigabytes for the operative system. So RAID 1.0 is the most efficient for random I/O patterns, especially the write-intensive application, like in the search database. The performance for RAID 1.0 and RAID 5 are quite similar when it comes to SharePoint in RAID-heavy environment, like content databases. So RAID 1 and 1.0, it requires that 2 disks will be written each time there is a host-initiated write. So the total will be 1 host read and 2 times host write, where RAID 5 will require 4 operation for host write. RAID 3 is also effective when you can use cache with it. But RAID 1.0 is the most used for mixed I/O types, I guess. This is all right. So a bit of SharePoint topology on this way. So on the outer rim, you have the farm, which is the biggest SharePoint container. And in each farm, you can have one-to-many web application. And each web application, you can have one-to-many site collection. And in every site collection, you can have 1 to 100,000 websites. And there is one too many, I can see here, sorry. So there is 2 times SP web, that shouldn't be. On each website, you can have 1 to 10,000 lists, which also can have 1 to 10,000 folders, or actually 0 to 10,000 folders. And each folder can have up to 100,000 list items. So that's quite a lot of elements in a SharePoint farm. So the data architecture of SharePoint. The idea of SharePoint is to be flexible, being able to use user-defined data types, like in the announcements, the contacts, the document types. You can have million or 100,000 of types in a single database. Maybe some types have 100 or more properties. And you have many items in a list, and you also want to be fast when you open a list. You want it to show it this way. So it has it's a lot of types. It's user defined. It's not administrator defined. You have to scale out. You have to scale up. You have to scale across when you do cross list queries. You can share field across the list. So it requires a lot from the database, and it's one of the reasons why it's so messy. If we look at the content database architecture, the blue box, it's about the containers, the sites, the webs, and the list. The second one, it contains the namespace for the elements. So the web ID and the site ID, it was what composes the URL of a special SharePoint list. And for each list, or for every list, there is a user data table where data is saved in such a way that they want to accommodate a lot of columns, so they're using sparse columns, so they can have up to 30,000 columns in one table, and it makes it quite messy. I don't know if any of you have tried to crack open the SharePoint content database and look at the structure and try to understand the schema, but it's not beautiful. So if you have these sparse columns, you also increase the number of index and statistics respectively to 1,000 and 30,000, and the maximal size of a wide table row is 8,000 bytes. Therefore, most of the data in any particular row is actually null. So this is a sample of the all user data table columns, where you can see that all those sparse columns, and it's just a little sample. It's much bigger. not easy to understand what's going on there. So it has some unique performance consideration that it increases runtime and compile time memory requirements. And applications, they can dynamically add rows or to the white table or remove them, and the performance is also affected by that. It's difficult to project the workload of such a table. Okay, and now I will show you that in a few seconds. Why is it not going? I want it on that screen also, but it doesn't want to. Okay, let's do it here. So here you can see that I've tried to make it nicely named, all the tables. And if we have a look at the first, it was the user data we were interested in. All user data, this one. And if you have a look at this is all the columns in this table. I don't know if you can see from here. Yeah, that's quite a lot of bits, and also UI GUIs and 2 geography columns and so on. So you have a lot of free space, and then everything is saved in this XML format in one column. So when you have a simple list, like let's see, this is. Wake up. It's working on it. Okay, I have a list of the Volvo cars through the ages. So if you look at it into why is it? Sorry. Here is the column set, which is composed of the sparse queries. So you can see that's one element. Actually, I imported it from Excel, so the key is a float, even if it's an integer. So this is the key number 29, and the elements of the SharePoint list, where it's a small family car, and it was built between 87 and 97. So this is how SharePoint stores list data. But this is not possible for indexing. It's very bad. So how does SharePoint solve this problem? Let me go back here. Sorry. Yeah. All right. Thank you. So you have multiple types in the same table. It's untenable SQL indexing, or what Brent called it yesterday, non-saggable indexing. So what the challenge here is, how do you put a SQL index on a given property? And actually, you don't. In SharePoint, you can index some columns. In the UI, you can say, okay, this is my index, because you want to find your data quickly when you're on your column. And it solves it by using name-value pairs. So it maintains a separate table with your list items and the keys for these items, and it will build an index on that. So which actually results in some very ugly queries in SharePoint. And joining on the on the name value pair table and on the item ID. So if you define a view, or if you use the SharePoint object model with doing a KML query, you will always use the name value pair in a join. It has quite a lot of overhead. Every time you add an item to your list, they will add an entry to this second table also. And also when it's edited or deleted, it will have to maintain 2 tables instead of just 1. So to recap, we have a white table with no type or awareness. We have row wrapping, multi-row objects, and we have name value pairs. So the result is the SQL Server knows very little about what's going on in SharePoint. It cannot use the query optimizer or the query planes to do it right. A few words about monitoring or maintenance of SharePoint. So for monitoring SharePoint, the best way is to use the SQL Server DMVs and some performance counters. I have a list on my notes. It's quite a long list, so I don't write it here. Check the integrity of your database on maintenance plane. On a regular basis. You can use CheckDB, DBCC CheckDB, but repair allow data loss is not supported by SharePoint, so you have to use some other method. Of course, these are time-consuming operations that has to be done outside the peak hours. And I'm very tired of this stuff going in my neck. Okay, so does SharePoint maintain indexes? It depends. Actually, it does and it does not. There is a store procedure in SharePoint called proc defragment index, and this store procedure is found on some databases and not on other. So it will run on the configuration database, the content database, the user profile, service application databases, the web analytics database, and a few other, but not, for example, on the search database, it's not there. So often the search and when doing crawling, it becomes fragmented, and you have to do something about that. Yeah?
Is it allowed for Microsoft, supported for Microsoft that we can do our own index maintenance?
Yes. Yes, it is. You cannot add indexes or remove indexes, but you can maintain them, the existing ones. Yeah, I will show you a list later of what is supported and not supported in database changes. If we want to, I find something quite interesting about this lot of this store procedure. Actually, it was, I don't know why they have written it in here, but I thought it was quite funny. I want to show you that. Defragment indexes. Where are you? Here. So I'm not sure people in the SharePoint group, they know what they are doing sometimes. But, this is not supported. Probably some early SQL Asia. So. Yeah, index. No, actually, it's the plural of index is indices in English.
Oh, really?
Yeah. But if you scroll right, it would say probably early SQL Asia feature. So I thought it was funny. All right, back to my slide. So you have to do something about the maintenance of these indices, or I will call them indexes anyway. Like the search database, you need to have a maintenance plans in some way. Fragmentation, it occurs by design in SharePoint because it uses clustered index in GUID columns, and when you use rolling window tables or random insert and so on, you will have fragmented index. So you have to reorganize when fragmentation is between 10 or 30% and rebuild when it's over 30%. And for that, you need some tools, make a maintenance plans. Maybe Ola Hallengren's framework is great for doing that kind of stuff. When you do database maintenance, you have to think about, I don't know if you can read it from the back, but it's quite a lot of text. You don't have the possibility to do auto defrag for other than the content database. You don't shrink content database. You only shrink content databases, not the other one, and you do it not as a part of a maintenance plan, and you do it also off peak hours. There is a timer service in SharePoint which updates statistics for you, but don't rely on it. Do your own statistic maintenance. And you can also use backups of SharePoint to do all the maintenance operation, or to do the DBCC, check DB, see if everything is all right there. And change the fill factor to 70 is also a good idea. What you shouldn't do is drop and recreate indexes. You shouldn't rebuild the indexes during business hour. And don't shrink anything except the content database. Don't auto shrink, and don't shrink if you don't need it. Okay, this is what you shouldn't do into SharePoint. That's quite a lot, but mainly it's making any changes to the database. You're not allowed to add triggers, add indexes, remove indexes, change primary or foreign keys relationship, moving, modifying or removing store procedure, and so on and so on. So it's basically a black box. And if you do it and you need support from Microsoft, they will deny every support if they find out that you have made changes to the database. There is an article which has a lot more points than my slide on what you are not allowed to do. But the key point here is that you should consider the database as a black box.
Is there anything you can do?
Yes, you can pray. No. And hope for the best, or you can also make a maintenance plan to maintain indexes and statistics, but you shouldn't modify anything. So you can maintain the indexes and recompute statistics, but you shouldn't change them. You can also change the recovery model of the databases if you, yeah. Oh yeah, it is. Okay, a few words about high availability. It has been supported for. Yeah, sorry.
I have another question
regarding
the index maintenance, because on previous Microsoft wraps, SharePoint wraps, risk assessment, something. We've been told to disable all index maintenance, or turn off all to create and all to update statistics, and just let SharePoint do the work. Is that totally wrong? Because Microsoft says so.
Yes, it is. I will not rely on SharePoint to doing index and statistics maintenance.
I should go enable all index maintenance right away.
Do a maintenance plan and do it the right way. And it's not every database in SharePoint which is maintained where index or rebuild or reorganize. So some of them you need to do it yourself. And it's allowed. All right, so high availability options for SharePoint. You have database mirroring, failover clustering, log shipping, and of course always on with SQL Server 2012, where database mirroring is still by far the most popular, and but always on is catching up with the more and more SQL Server 2012 being used. Sometimes another another high availability solution is to virtualize everything and just rely on the virtualization platform for high availability. So when one host is down, then the other host just takes over. That's also a possibility. So in the farm server in this example, it's deployed on physical computers or on virtual machines. The idea here, the 4 front-end web servers, W1 to W4, they are dedicating for serving content, and they are redundant. So it allows the farm to continue working when you're patching or updating it. And 4 application servers, A1 to A4, are used for the farm application, and also with the same advantages for that. So you can, by using database mirroring and clustering, you can have some good high availability features to eliminate a single point of failure this way. So you can have a cluster of clusters, so you can share a disk rather than having a standalone machine. So you will have instance redundancy and data redundancy. So like that, you can resist up to 3 machine failures, and it will still work. If you only have a cluster with 2 nodes, a single node failure will result in lost mirroring. So this way you have your always-on listener and your 2 logical nodes and your physical cluster.
That cluster, is that a VMware cluster or is it a SQL cluster? Second one, cluster with 2 nodes.
It's a SQL cluster.
Well, a single node won't be a failure over the mirroring. Once it's up, it's a shared storage.
Yeah, but this one is not. Sorry, it's not in shared storage in my slide. So you have 2 nodes with two single storage.
Then it's not a SQL cluster.
Sorry, so.
Then it's not a SQL cluster.
No, sorry, no, it's a Windows cluster. Yeah, okay. Yeah. Sorry, my bad. And I show you in 2 seconds in. So for recovery time objective and a recovery point objective, the different SQL Server solutions have some advantages and inconvenience. Just to mention that readable secondaries also, it's a good thing to have, is not supported at all in SharePoint. So you shouldn't use it. And there is also another way to acquire, to obtain high availability in SharePoint, and it's a stretched farm. If you have a very short farm latency, in some enterprises you have data centers which are very close to each other. You can, or high bandwidths, if it's available, you can configure the 2 data centers as a single farm actually. So this distributed topology is called a stretched farm.
What latency, where is the latency rate?
Under 1 millisecond. So that has to be very close to each other. Oh. And the latency is the latency between the front-end web server and the database servers. Okay, so let's have a look at always on. So when you want to add all your SharePoint databases into always on, it will start by complaining, except no, sorry, I want this one. it will start by complaining that the full recovery mode is required for the SharePoint databases. So that's one of the first changes you have to make on the database. You have to have the full recovery mode, and of course a backup.
Are we allowed to do that?
Yeah.
If you put the model database in full recovery,
Then you're then you're good. Yeah. Okay. Do you mind if I change the resolution of this screen? Oh, okay. He minds.
no, it doesn't matter.
No. I do something. No. Okay. So that's bad for my neck again. So this cluster is configured in a very simple way. Actually, it's 3 virtual machines. I got a domain controller and a SQL server, and my SharePoint server where SQL server also is installed. So very simple setup. 2 nodes, my SharePoint and SQL server, and my SQL 2. And I got availability. It's always difficult to say. Availability group on my SQL server, and I run with a file share witness for the quorum model because I have these 2 nodes. So in the SQL server, if I get up here. You will see that's all. They're all synchronized, and here I got my availability group, which hopefully is working. Yes. So with my 2 databases, one is a primary, and in this case, I've made a manual failover because each time I close my laptop, it will try to failover. So it's not very interesting, and it's synchronized in this case. So I can do a failover, and hopefully it will work. I take my very simple list. Okay, and let's kill one of them. Let's failover. I want to failover to the SQL 2. So far, so good. I need to connect. This also should be possible. And I can choose to script it or just run it. All right. So now if I refresh this, it should refresh shortly. Okay, let's refresh this one. So now it says my SharePoint is the secondary, and my SQL 2 should be the primary now. So this part has worked, and let's see if SharePoint also is responsive. I will hit F5 in 2 seconds. SharePoint is very chatty with the SQL Server, so once in a while you have some bad surprises. But it looks like it has worked. I'm happy. It worked. Almost. Which one is complaining about? Now it's synchronized. Good. So everything is peachy, and I'm a happy camper. All right. Okay. So that was my last slide. You have any questions before lunch, or you're hungry?
The
Yes?
Would it include running the SharePoint install procedure to defragment the DBA?
No, SharePoint, it has a timer job and does it itself for you. Yeah, so if you want to implement a maintenance plan, do your own and use another product.
I understand that.
Okay, so thank you.